Hello everybody, welcome to section 10.4. Today we're going to be talking about inscribed angles. So an inscribed angle is any angle where the 2 points of the angle, they're going to be parts of the circle, and the vertex is also parts of the circle. What I mean by parts of the circle is they are directly on the circle. So A, B, and C of the angle are always going to be on the circle. A little bit different than the central angle we talked about before. What is unique about this one is that angle ABC is no longer going to be equal to the arc it's intercepting, arc AC. Instead, angle ABC is going to equal half of the arc. In other words, arc AC, where ABC is grabbing onto and intercepting, that's going to be twice as big. So multiply whatever this angle is. I wrote that wrong. 1/2 arc AC. That should be the correct writing. Because if you take angle ABC and multiply it by 2, you get this arc. And if you take the arc and divide it by 2, you'll get the angle. So again, the inscribed angle is when the vertex with its vertex is on the circle and 2 sides that are also on the circle. Or in the circle, right? They're inside the circle. The intercepted arc is the arc that lies between the points, the end points, the points at the end of the angle, and the degree of the inscribed angle is always going to be equal to half the measure of the inscribed arc. A couple other important things are going to happen here. Sometimes we'll see overlapping inscribed angles like this one here. So notice that angle ABD is coming out and intercepting arc AD. And angle ACD is also intercepting the same arc. It kind of looks like a bow tie. Whenever you see that, well, because they're both intercepting arc AD, we know that those 2 angles have to be equal, congruent to each other. They have to have congruent measurements. So if they intercept the same arc, then they are congruent. So in other words, we can see that we highlighted ABD in orange. That's going to be equal to the measure of angle ACD in green. One other important thing that comes from inscribed angles, and that is whenever you see a quadrilateral inside of a circle, when it's inscribed in a circle with all 4 points of the quadrilateral as points on the circle. What ends up happening then is that the opposite angles are going to be supplementary to each other. So in this one, we're going to say that angle A is supplementary to its opposite angle, which is angle C. And likewise, angle B is supplementary to angle D. Now, the reason this is happening is because the way it's intercepting. Let's just look at A and C, right? You've got angle A right here, and it's intercepting this arc right here, right? It's intercepting arc DCB. On the other side, you've got angle C, which is intercepting arc DB. Well, what we can see is that angle A and C are intercepting the whole circle together. C has this half and A has this half, which means together they add up to 360 degrees of arc that's being intercepted. Well, we know that the angles are equal to half that. So if you take half of 360, you get 180, which means that they are supplementary. All right, let's take a look at these first examples. Starting off with a nice simple one right here. It says find the measure of angle WXY. That's going to be this angle right here. Well, given that they have the arc, when we're going from an arc to an angle, we're going to half the size. So we're just going to take 62 and divide it by 2, and that's going to give me 31. So I know that this angle is 31 degrees, exactly half of the arc it's intercepting. Same thing's happening over here. They're asking us to find JKL, but they didn't tell me, right? JKL comes out and intercepts JM, and then all the way back around to L. Well, I don't know how big that angle is, that arc is, but I know these 2 angles. I keep saying angles, these 2 arcs. If I know these 2 arcs, then I know this arc as well, because they have to add up to how much on a circle? 360 degrees. So I'm going to add those 2 together. 65 and 53 added together. That's going to give me 118. And we'll subtract that from 360. So it looks like here I'm gonna have 42 and then 2, so 242. So I know that arc JML is 242 degrees. Now again, if we're going from an arc to an angle, that means we have to divide it by 2. Whenever you're going from the arc thing, you can see it's getting smaller, right? It's going, whoop, sucking it in. So it's getting smaller. So we're gonna take 242 divided by 2, and I'm gonna get 121 degrees. So I know that this angle is 121 degrees. Not too hard, just dividing by 2 to go back to the angle. All right, example 2 and 3 has to do with those little, example 2 has to do with that little bow tie thing. 4 is the other one with the bow tie thing, right? So it says, find the measure of angles RST. RST is gonna be this angle here, and of RUT, which is gonna be this angle here. Well, again, the thing is, we know that both RST is coming out intercepting arc RT, and angle RUT is intercepting the exact same arc. They're both coming out and intercepting this arc right here, meaning that's where their two endpoints of the angle lie. So if I know how big this one is, I can find both of those angles. Again, they gave us the other 3 arcs, so all I have to do is add those up and then subtract it from 360. So I'm gonna add those things together. 4 and 5 is 9, 9 and 9 is 18. 1 and 6 is 7, plus another 7 is 14, plus a 3 is 17, and 200. So 360 minus 278, that looks like it's gonna give us 222, 82. So that means that this arc has to be 82 degrees so that all the arcs add up to 360. If we're going from an arc to an angle, we're getting smaller, so we should be dividing by 2, and I'm gonna get 41 degrees. So I know that each of these has to be 41 degrees so that when I multiply them by 2, I get that arc. Taking a look at this one, it looks like they've given us a few things that we can figure out, right? We're gonna have to do a few things. Ultimately, our goal is to solve for x. Well, if I wanna solve for x, we wanna look at the arc, the angle that angle's intercepting, right? This angle, if I extend it out, you can see that the arc where the 7x plus, the angle where the 7x plus 6 is plugged into, the arc it's intercepting is this arc right here, x to y. So if I know how big x to y is, then I know how big that angle is, and we can set them equal. Well, they didn't really give me all the information I need. They gave me the 78 out here, but they didn't tell me how big this arc is. If they did, we could subtract them from 360 and get this one. But they did tell me that this is 114, and look what arc that's intercepting. If I extend this out, that's this missing part right here. So remember, when we're going from angle to an arc, we're getting bigger. So we're gonna take 114 and multiply it by 2 to get 228. So I know that this arc is 228 degrees. Great, all I gotta do then is add these up, subtract it from 360, and then I know how big that one is. So 228 plus 78, it's gonna give me a 16. That's gonna give me a 10, that's gonna give me a 3. Ooh, that's easy, right? Oh, wait, that's not a 300. I thought it was a 300. Nope, 306. A little bit tougher, but still not hard. 360 minus 306. We're gonna get 54, so I know that this is 54. Again, before you just jump into setting equal though, because if you set 7x plus 6 equal to 54, you would not get that right. We have to make sure that we take this arc and divide it by 2 to figure out how big this angle is. So when I do that and divide 54 by 2, I get 27. So I know that this angle is 27 degrees. That was not drawn very well. I'll put it up here. 27 degrees, which means we can set those two things equal. 7x plus 6 has to equal 21. So 7x plus 6 equals, not 21, 27, sorry. So we subtract 6 from both sides. That's where I got the 21 from. Divide by 7. And I get x equals 3. So I know that x equals 3 for that problem. Taking a look at example 4, I see another one of those little bow tie patterns. It says that angle ABD right here is going to be 6x plus 26. And angle ACD, this one here, is going to be 13x minus 9. Guys, this one's super easy. We know that this is intercepting arc AD. This is intercepting arc AD. They're both intercepting arc AD. So those two angle measures, 6x plus 26 and 13x minus 9, have to be equal to each other. So we're just going to solve that equation, and then we'll know how big x is. So I'll subtract 6x from both sides. I'm left with 7x minus 9. We got to get that 9 out of there then, so we can get 7x by itself. We get 35 equals 7x. And, of course, divide by 7, and we get x equals 5. Now, again, don't jump into this. Be careful. Always make sure you go back and read it, because it didn't say how big is x. It said, what is the measure of arc AD? Remember, arc AD is this one right here. So we need to plug this 5 back in and figure out how big the arc is by multiplying it by 2. So let's plug 5 in. 6 times 5 plus 26. So I used this equation. You could use either one, though. It wouldn't matter which equation you plug it into. So 30 plus 26, and I get 56. So now I know this angle's 56. Well, to get it to an arc, we want to take it and multiply it by 2, and that gives me 112 degrees. And the last one on here is this quadrilateral. So it says solve for x. Again, we know that the quadrilateral, there's the property that has to do with their opposite angles are supplementary to each other. Well, this one's kind of tricky because they didn't tell me, right? They told me the angle L is 15x minus 23. That's what goes in here. But if I want to figure out what is happening, I need to know what angle N is. Well, guess what? They gave us the information we need for angle N. If we extend angle N out, you can see that it intercepts arc 91 and 135. So if I take 91 and 135 and add them together, I know how big the arc the angle N is intercepting is. So 135 plus 91, 6, 12, 2, 226. And of course, oh, nope, don't have to do that. When we're going from an arc to an angle, sorry about that. When we're going from an arc to an angle, we know I have to divide by 2. So we'll take 226 and divide it by 2, and I get 113. So now I know that this is 113 degrees. Now we can do this property. Opposite angles, whenever you have a quadrilateral inside of a circle, where all 4 points of the quadrilateral are inscribed on the circle, these two have to be supplementary. So I'm going to add them up. 15x minus 23 plus 113 equals, and it's supplementary, so it equals 180. So start by combining these like terms. So 113 minus 23 is going to bring me to 90. Subtract 90 from both sides. Cancels, and I get 15x equals 90. And divide both sides by 15. And I get x equals 15, 30, 45, 66. X equals 6. And again, checking that that's all they wanted to solve for it is. So I could stop right there, and that's going to be my answer. As always, let us know if you have any questions. Happy to help you all. Have a great day.